Spirent Communications, NFVI Starter Kit Test Methodologies, Infrastructure Metering Validation. This procedure validates the functionality and accuracy of an NFVI metering service. In this procedure, a test case that sends an exact amount of IPv4 frames per second will be authored and executed, validating the metered rate on the OpenStack Ceilometer service. This procedure results in a working test case that injects a deterministic bidirectional frame rate into the infrastructure. The infrastructure metering system, in this case Ceilometer, is queried after the test, and a pass-fail verdict is applied based on a plus or minus 1% margin of error. The device under test, in this example, is an infrastructure metering service called Ceilometer. Ceilometer provides usage statistics for virtual components such as CPU, memory, storage, and networking. In this procedure, a virtual topology will be created using two Spirent Test Center VMs connected through an OpenStack network. In Velocity, define the OpenStack clouds for which you have access. The information needed in this step includes the identity API endpoints, tenant names, and user credentials for each cloud to be used as a virtual test bed. If the cloud has already been added in this screen, you may see a red warning symbol next to the cloud. This indicates that updated user credentials need to be associated with that cloud. If this is the case, edit the cloud and provide the accurate user credentials. Individual credentials are stored in Velocity for each user. After user credentials are added to each target cloud, images can be listed, edited, deleted, and added by clicking on the Images tab. Images can be uploaded from a local file or from a URL. VM templates are definitions of combined attributes such as image name, key pair, security group, hardware requirements, OS, and more. VM templates are used as abstraction layers where any cloud can be specified as the cloud target. An image name can be specified as a regular expression. Well-defined VM templates promote reuse and flexibility applied to many NFVI test applications. Furthermore, when using the regular expression match for image name, a dynamic test environment can be leveraged as new images are imported to OpenStack through Velocity's REST API as a part of a continuous integration strategy. Add a new VM template and name it STCV for the AnyCloud target. Specify 3 CPU cores, 2 GB of RAM, 8 GB of disk, and STCV as the image name. This will allow us to deploy STCV on any cloud target using the current version of the STC VM. Create a new topology called STC back-to-back, containing 2 STC VMs, the external network providing reachability to the public network, and a single tenant network. Start by adding the public network, virtual network, and a virtual router to the topology canvas. This will provide us with IP access to both of the STC VMs. Rename virtual network to MGMT and rename virtual router to router. Connect these 3 elements together with links and then add the VMs. Name the STC VMs STC V1 and STC V2 respectively. Connect each VM to the MGMT network. Add one more virtual network from the AnyCloud target into the canvas and name it Test. Attach STC V1 and STC V2 to the test network. At this point, both STC VMs will have 2 interfaces, VNIC1 and VNIC2. Floating IP addresses must be assigned to both of the virtual machines for external IP access. Select STC V1 and open the Ports tab in the left pane of the topology editor. Show the port properties of VNIC1 by clicking the information icon and choose Public Network as the source of its public IP network. Repeat the process for VNIC1 of STC V2. At this point, the topology should look identical to the topology image at the beginning of this section.